Have you ever just wondered why some things are so perfectly consistent while others are a complete roll of the dice? Well, we're about to dive into a seriously powerful method for taming that chaos. And it doesn't matter if you're making a microchip or just a great cup of coffee, it's called statistical process control, or SPC, and it's the real secret to moving from constant firefighting to genuine, lasting improvement. So here's how we're going to break it down. We'll start with the big problem, the quality conundrum. Then we'll unmask the secret enemy behind it all, variation. After that, I'll show you the tool that lets us see what's really going on. We'll then ask the big question, is our process actually good enough? And finally, we'll see the incredible power all this knowledge gives us.
All right, let's jump right into part one, the quality conundrum. We all know that getting consistent results is tough. The real question is, why? Why is it so hard?
Think about it this way. You've got a favorite coffee shop, right? Most days, your latte is just perfect. But then some days, it's just wrong. Too bitter, too milky, something's off. It's the same place, the same machine, maybe even the same barista. So what gives? This isn't just a coffee problem, you know? It's a universal problem that shows up everywhere. The entire mystery, the whole reason for that inconsistency, boils down to this one single word: variation. It's this invisible force that messes with everything we do, from our morning brew to the most complex manufacturing lines. It is, for all intents and purposes, the villain of our story. And that leads us perfectly into our next chapter, taming process variation. See, once you accept that variation is everywhere, the next big leap is realizing that not all variation is created equal. Our job is to figure out who the real troublemakers are. It turns out our villain has kind of a split personality. On one side, you've got common cause variation. Just think of that as the normal, predictable background noise of any system. But on the other side, you've got special cause variation, and these are the loud, disruptive signals that tell you something has gone seriously wrong. So let's look a little closer at common cause. This is the natural wobble that's just baked into the system. You know, tiny little shifts in temperature in the materials, or even just the focus of the person doing the work. It's always there, and trying to fix it is like trying to quiet the hum of your refrigerator. You can't, not without changing the whole system. Now, special cause variation, that's a whole different beast. This is a machine suddenly breaking down, it's a bad batch of raw materials showing up, it's a new employee who wasn't trained right. These are the big, unpredictable shocks, the real culprits that we can actually hunt down and get rid of. So how in the world do you tell the difference between that background noise and a real urgent signal? Well, that's where our superpower comes in. It's time to talk about charting a stable path. This quote just nails it. The hero of our story is a tool called the control chart, and its genius isn't just that it flags problems. Just as importantly, it tells you when to leave things alone. It stops you from freaking out and reacting to that normal background noise, which, believe it or not, often just makes things worse. And it's really not as complicated as it sounds. First, you just plot your data over time. Then you calculate the average. That's your center line. Now here's where the magic happens. You use the natural variation in your own data to calculate an upper and a lower control limit. Any data point that falls outside those limits, that's it. That's your signal. That's a special cause that needs your attention right now. This brings us to a really powerful idea. The control limits are the voice of the process. These lines aren't some goal you wish for. They're what your process is literally telling you it's capable of doing, good and bad. It's showing you the natural boundaries of its everyday wobble. Okay, so we've used a control chart, we've hunted down the special causes, and now our process is stable and predictable. We're done, right? Mission accomplished? Well, not so fast. This leads us to maybe the most important question of all. Is our stable process actually any good? And this is absolutely crucial. Your process can be perfectly stable and predictable while consistently producing garbage. Seriously, imagine a pizza delivery service that is predictably, reliably 30 minutes late every single time. Their process is stable, but are they meeting your expectations as a hungry customer? No way. And this is where we bring in a second, totally different set of goalposts. We already have the control limits. That's the voice of the process. Now we add specification limits. This is the voice of the customer. This is what the customer needs you to do, like getting that pizza delivered in 30 minutes, not 60. This finally brings us to the concept of process capability. And it's a simple but really powerful idea. It just measures how well the voice of your process
fits inside the voice of your customer? Does your natural performance, your natural wobble, fall comfortably inside what your customer needs?
So how do we measure this? We use something called a capability index, usually CPK. Now, don't worry about the formula. Just focus on this magic number, 1.33. In many industries, this is the gold standard for what's considered a capable process. A CPK of 1.33 means there's a really comfortable buffer between your process's performance and what your customer demands. We're talking a defect rate of around 63 parts per million. It tells you your process isn't just stable, it's excellent.
All right, let's bring this all home in our final section, the power of predictability. Because when you combine all these tools, when you understand variation, use control charts to get stable, and then measure capability, something really amazing starts to happen.
The payoff is huge. You cut down on waste because you stop making bad stuff. The quality of what you do goes way, way up. Your outcomes become predictable, which makes planning a breeze. All of this leads to lower costs and, you guessed it, happy customers who trust you and keep coming back for more.
So if you only remember 4 things from all this, make it these. 1. Variation is everywhere. You have to understand it, not fight it. 2. Control charts are your secret decoder ring for telling the difference between noise and real signals. 3. And this is so important, a process can be perfectly stable but still not capable. And finally, number 4. Using SPC transforms you from a frantic firefighter, always putting out the next blaze, into a calm, proactive process improver.
So I'll leave you with one final question to think about. Whether it's at work, a personal hobby, or maybe even just making your morning coffee, what chaotic process in your world could you finally bring under control just by learning to listen to what it's trying to tell you?